What is a sine ratio? Well, it's really pretty easy. All it is the length of the leg opposite angle A over the length of the hypotenuse. So if we were to look at this drawing, here's angle A. The length of the leg opposite it is the red one. So keep in mind the red over the green, okay? The leg opposite A is this one, because it's on the opposite side of the triangle. And you put this length on top of this length, okay? So let's say the length of this leg was 6, and the length of this one was 10. It would be 6 over 10. It's that simple. And then what you would do is you would reduce this to 3/5, and then the sine would be 0.6. See? So I'm going to show you that in a second. I want you to remember, if all the sides are increased in proportion with each other, then the ratio is going to stay the same. If the measure of the angle that the measurement was taken from, if that gets smaller, then the sine ratio gets smaller. So let's take a look at this. Let's say you were at 50 degrees. Look at how big this angle is, and look at how big this opposite leg is. If we make it smaller and go down to 25 degrees, now look at how long the hypotenuse is, and look at how short that opposite leg is. So the measure of the angle getting smaller is going to affect the ratio. But the sides increasing or decreasing in proportion to each other, it doesn't matter. If you increased all of these sides in proportion, then this would stay in proportion. Remember, it's only if the angle gets smaller, then that's going to change, because then the sine ratio is going to get smaller. So I want you to remember that it's the opposite over the hypotenuse. I want you to remember that if you see SIN, it's just a short way of saying sine, and if you see COS, it's a short way of saying cosine. And I want you to look in the corners here. See these little marks here? These are Greek letters of the Greek alphabet, and they represent the measure of an angle. So here's a little chart. See, this one looks like a fish, but the tail isn't quite finished. Here's a fancy B. So we have alpha, beta, phi. That's got a vertical line running through it. Gamma kind of looks like a ram horn, doesn't it? And then theta has a horizontal line going through it. And they can represent the measure of an angle. So if we don't know what the measure of angle A is, we can just put the theta sign there, or a beta, or the gamma, to represent the measure, okay? So, now let's take a look at this drawing. This is the typical right angle 3, 4, 5, okay? This side measures 3, this side measures 4, and this side measures 5, okay? This is B, it's 3, A is 4, and C is 5. And C is the hypotenuse, okay? This is the adjacent to angle A side, because it's right next to it. Here's the opposite one. Okay, we have the hypotenuse. All right. This would be the sine of angle A is the ratio of the side opposite A over the hypotenuse. So it's going to be 4 over 5. Okay, so it's red over green. So it can be written as like this. Okay. See how we have the theta mark there? So it's going to equal A over C, which is 4 over 5. See? 4 over 5. 4 over 5 in decimals is 0.8. It's 80 out of 100. See? 4 over 5. Now if we were to do B, it would be 3 over 5. Because B equals 3 and the hypotenuse is C, it's 5. So we would write it as B over C, or 3 over 5, and 3/5 is equal to 0.6. So that would be the sine of angle B, because angle B is up here and its opposite is down here. It's the purple. See how I got that? The sine of angle B is the ratio of the side opposite B over the hypotenuse, just like A was the side opposite over the hypotenuse. All right? This purple one is the side opposite B. So the sine for B is 3 over 5. The purple one over the green one. Where the sine for A is the red one over the green one, 4 over 5. See how I got that? This is not that hard, is it? No, this is pretty simple. So, that is a sine ratio.